Hi, CP Calculus class. This is Monday, March 23rd video. It is on section 5.2. It's on integration by substitution and the general power rule. And so before we can actually get into that, it's more integration. It's just a new technique. I hope you mastered the one that we did in section 5.1. So this is a little more sophisticated. So before we do that, we have to review what a composite function is. So simply a composite function is a function within a function. So I've just given you some examples of composite functions here so we can identify what we're calling the inside function. So when I look at, here, let's not look at them all at the same time. Okay, so when I look at y equals the sign of the quantity 4x squared plus 1, this is not the sign times the quantity. This is the sign of. This parentheses is inside. This function's inside the sign function. It's composite. So our inside function is 4x squared plus 1. Let's look at another one. This is y equals 3x squared plus 2 to the 5th power. The function that's inside is 3x squared plus 2 because it's inside the power function, which is our 5th power. But the inside function is just the 3x squared plus 2, not the 5, not the exponent there. Okay, let's look at another one. Y equals the square root of 2x plus 1. The inside function is 2x plus 1, not including the square root because the 2x plus 1 is inside the square root. There's our inside function. Okay, one more. Well, maybe a couple more. All right, so y equals 4x minus 2 to the 2/3 power. I bet you know now what the inside function is. If you said 4x minus 2, you are right. That is the inside function without the 2/3 attached to it. And the next one is 6x times 3x squared plus 2 to the 5th. Okay, it's a little more complicated than the other ones because we got the 6x hanging out here. But the only expression that's inside a function is the 3x squared plus 2. That is the inside function, not the 6x, not the 5, just the 3x squared plus 2 is our inside function. Do we have another one? Let's check it out. Oh, one more. We have y equals 2 times the square root of 2x plus 1. So our inside function is 2x plus 1. Not the 2, not the radical, just the 2x plus 1. So the objective was for you just to be able to identify the inside function. But now that you can do that, we're moving on to the problems. Okay, so hopefully, as I'm saying, you can identify the inside function because you'll need to do that for our new integration technique called integration by substitution. All right, let's see how this starts out. All right, so we have a function that looks like this. Integral of 3 times 3x minus 1 to the 4th power dx. How do I know it's different from all those problems that we did in section 5.1? Because all the problems in section 5.1 did not have a function inside a function. That's how it's different. So what do? Well, the goal is to make this look like a problem that we did in section 5.1 and then integrate it. So we're going to simplify this by using a substitution, and this is how it works. You pick the inside function, which now I'm sure you know is 3x minus 1. And we let u equal the inside function. So u is going to be 3x minus 1. Do not include the exponent, do not include the 3 out here. Then we take the derivative of what we picked for u. So you know how to take the derivative of 3x minus 1. The derivative of 3x is just 3, and the derivative of minus 1 would be 0. So looking at that, we just get 3 for our derivative. And it's written du dx. But we're going to simplify that a little and multiply by dx so that our du is 3 dx. So really, when you get the hang of this, the only two things you have to write are that u is 3x minus 1, and the du is the derivative of that, which is 3, and then put the dx on the side with the 3. Okay, so those are the two important pieces of the puzzle right here. Now, we go back to the problem, And we say, okay, let's substitute u back in. Well, u was 3x minus 1. So the 3x minus 1 comes out, and the u goes in place of it. The 4 is still there. Big question, what about the 3dx? Well, every integration problem needs a little integral sign and either a dx or a du or a dy, a d something. So what we have here is a du. We have our du right here. It's equal to 3dx. So if I put du over here, it's exactly the same. It represents 3dx. So now this says the same thing as this using this substitution. Now this might take a little while to get the hang of, but if you do a couple more with me, you'll see it'll click. So now what we have is a problem we know how to integrate. We integrate this like we did in section 5.1. How is that? We add 1 to the exponent and we get 4 plus 1. Divide the current coefficient by the new exponent, we get 1/5, and now we have 1/5 u to the 5th power plus c. But we started the problem with x's, we need to end the problem with x's. So now at the end, after we integrated and put our plus c in, we take the u out and we put in 3x minus 1. That's what u equals in terms of x's. So our final answer, now substitute 3x minus 1 back in for u. Our final answer is 1/5 times the quantity 3x minus 1 to the 5th power plus c. Now, it's true that if we took the derivative of this answer, we should get the original integrand back. But today we're not going to do that. We're just going to go this far. We don't have to check our answers. We're just going to go this far. Tomorrow maybe we'll do some checking on this. All right. I am not leaving you there. We have a few more to do. So, all right, let's try another one. So here's the problem. Number 2. The integral of 3x squared times the quantity x cubed plus 1 to the 5th power dx. That looks pretty complicated, but if you can identify the inside function, you're going to be golden here. So, u is our inside function, and our inside function is x cubed plus 1. Now, we take the derivative of that. Don't even go back and look at that problem yet. Just take this and then take the derivative of x cubed, which you know is 3x squared. The derivative of plus 1 is 0, and we throw in a dx here. Okay. Now we go back, now substitute back into the problem. Well, u represented x cubed plus 1. So the u comes out, the x cubed plus 1 comes out, and the u goes in place of it. The 5 is still there, didn't go anywhere. And now what about the 3x squared dx? We need something to represent that. And guess what? We like this problem because the du exactly equals 3x squared dx. So by putting du in the problem, we have covered the rest of the problem. And now we just integrate the simplified version here. So add 1 to the exponent, get 6, divide the current coefficient 1 by the new exponent, and we have 1/6 u to the 6th power plus c. But don't leave the u, because we started with x's, we want to end with x's. So the u comes out, and the x cubed plus 1 goes back in its place. 1/6 x cubed plus 1, quantity to the 6th power plus c. Okay, I know these are a little tough, so let's do another one. Here it is. Except I kind of threw it in a little tougher with a radical, didn't I? All right, so integrating 4x cubed times the square root of x to the 4th minus 2. Again, u is the inside function. X to the 4th minus 2. Again, don't go back and look at this. Come over here and take the derivative of what you picked for u. The derivative of x to the 4th minus 2 is 4x cubed, and then we put our dx in. So our du, our derivative of u, is 4x cubed minus the derivative of 2, which is 0. Okay, so we get 4x cubed dx. That's our du. Now, substitute. So, before I substituted, I wrote the square root as x to the 4th minus 2 to the 1/2 power. Okay, now this expression is the same exact as that integral right there. Now we can substitute. There's my arrow. All right, so now that x to the fourth minus 2, that's going to come out. And that becomes u. So there's my u to the 1/2 power, and the 4x cubed dx is 4x cubed dx. That is represented by du. So put the du there, and now we've got the whole problem covered by our substitution. And now it's a much simpler problem. We just integrate u to the 1/2. So add 1 to 1/2, we get 3/2. Divide the coefficient, current coefficient 1 by 3/2. 1 divided by 3/2, we get 2/3. So our integration gives us 2/3 u to the 3/2 plus c. Don't leave the u's, put the x's back in for u, and we get 2/3 x to the fourth minus 2 to the 3/2 power plus c. Voila. Okay, that's number 3. Now, I think I have one more left, and actually I think it's easier. I maybe should have started with number 4. Okay, so number 4 is the integral of x minus 3 to the 4th power dx. So now our inside function again, it's x minus 3. But I wanted to show you this one because when I take the derivative of x minus 3, I get the derivative of x, which is 1, and the derivative of minus 3, which is 0. So I have 1 dx, but sometimes people don't know what to do with the 1 dx. Just write 1 dx as dx. So really our substitution simply looks like u equals x minus 3, and derivative of u is just equal to dx. You don't have to write the 1. Just like when you have 1x, you don't put a 1 next to the x, right? So this is 1 dx, but we're just going to leave it as dx. So now we go back, and now we substitute. So u is x minus 3, so that's u to the 4th. Du, well, it didn't have to cover any numbers over here, but it does have to take the place of dx because we need this and the integral sign in the problem. So there's my du. This expression says the same as this one. All right, now we just integrate. Add 1 to the exponent, u to the 5th. Take the current coefficient, 1 divided by 5, we get 1/5 u to the 5th plus c. Put the x's back in, we have 1/5 times the quantity of x minus 3 to the 5th power plus c. There you go. There are 4 examples. You don't have to check them. The directions does say differentiate to check the problem. You don't have to do that. You just have to establish your UDU substitution, substitute, integrate, and put the x's back in. All right, so what do we have? Yeah, you can check them, but I'm not asked, but you don't have to check the problems. So the assignment is section 5.2, page 329, numbers 9, 11, 15, and 16. And I hope you have a great day. And if you have any questions on these that I'm giving you, email me and I will do them out for you. I definitely will do number 16 because that's an even one and you don't have the answers to that one. But if you need 9, 11, or 15, you can also let me know. And have a great day.